Okay, so let's get started. Welcome, my name is Giedrus, or simply GM, and I will be your host today. Also, I will be joined by Travis, who will help me with the Q&A session. Today, we will be, oh, sorry, Travis?
Sorry. Hey, folks. I'll be in the background. If you've got questions, I'll help answer as they come up. And then at the end, we'll dive through all those. So back to you, Idris.
Oh, thank you, Travis. So today we'll be looking at antennas, the theory behind them, and how to choose the right one for your project. Peplink's mission is unbreakable connectivity anytime and anywhere. We have a range of products, solutions, and services for our clients to achieve this. We will start today by looking at the theory, and then we will move on to the applications and how the theory affects your deployments, what is related to antenna topic. There are two main antenna types, omnidirectional and directional. Antennas can be thought about like a light bulb. If you have a light bulb that doesn't have a reflector and shines light equally at all angles, this would be similar to a 0 dBi gain antenna. The gain can be thought about as how much you focus the light in a particular direction using a reflector. The light will be brighter in the direction the light is focused, and there will be less light going into other directions. Also, it is important thing to note that antenna doesn't amplify the signal or create energy. It actually helps you to focus transmission and reception. So when we get back, the first type I would like to mention is omnidirectional antenna. It is designed to transmit and receive 360 degrees around the antenna. Its radiation pattern can be thought about like a donut. In the illustration we have here, you can see what happens to an omnidirectional antenna's radiation pattern as the gain is increased. The increase in gain flattens the donut. Simply put, the higher the gain, the lesser the angle of coverage, but the greater the distance covered. Now, the next type is directional antennas. These are designed to transmit and receive in particular direction. Its radiation pattern can be thought about like a cone. In the illustration we have here, you can see what happens to a directional antenna's radiation pattern as the gain is increased. The increase in gain extends the cone, but makes it more narrow. Similar to omnidirectional antenna, the higher the gain, the lesser the angle of coverage, but the greater the distance coverage. Important thing to note is that gain is measured in logarithmic scale. And very important to know that every 3 dB, you double the transmitted and emitted signal. And as mentioned before, the higher the gain, the smaller the angle, but the longer the distance. Now let's move to the radio parameters. The first one is VSWR, or I will say simply VSWR. It indicates energy reflection. For instance, when LTE modem is transmitting, some of the energy is reflected from the antenna back. This happens due to impedance mismatch, which is very difficult to achieve over the large frequency range. Important to note that it is possible to damage cellular modem if the VSWR is too high. It is advised to have VSWR below 3. And typically the good value is about 1.5 up to 2.5. The next one we would like to talk is efficiency. Not every antenna vendor provides efficiency information, but this is one of the key parameters to consider. It actually states how efficiently antenna is converting received signal into electrical currents and vice versa. The efficiency is provided in percent. So, for instance, if the efficiency is 30%, that means 70% of the received energy is actually lost or converted to heat. The interesting thing is that in theory, the antenna may have a high gain and even a good VSVR, but if the efficiency is bad, it will lead to poor signals and bad performance. In most cases, the efficiency varies from 30% up to 80 or 90% depending on a frequency band and antenna type. Next, talking about the different frequencies, we would like to split them into several ranges like low, mid, and high bands. This is done for simplicity reasons, and this is not official splitting. And in further slides, we will talk about the different band properties, and we will tell you just like low band or high band, so you will know what it actually means and about which frequencies we are talking about. Another thing to mention is attenuation. Attenuation is a gradual loss of your signal strength, and there are a couple of factors which affect it. The first one is frequency. The higher the frequency, the higher the attenuation. Second one is distance. The longer distance will lead to high attenuation, and I'm sure you have already seen this in practice. And the last one is physical surroundings. For example, trees, walls, buildings, anything. In other words, anything what's between antenna and the cell tower will actually affect your signal. Installation areas we can divide into several main groups, such as low, medium, and densely populated areas. Each of these groups will have several factors which need to be considered when choosing the right antenna. For instance, the low populated areas will have less cell towers. To achieve this, low bands are used. Low bands provide large coverage and reaches distant areas because of a lower attenuation and high penetration. The main disadvantage for us is lower performance, a lower throughput, if I can put it this way. This is because mainly narrow bandwidth channels are used by operators, and therefore the connectivity speed will be lower as well. On opposite side, in densely populated areas, you will find more cell towers to avoid cell congestion. And in these locations, higher bands will be used which have higher attenuation and lower coverage. In most cases, the connectivity speed will be higher due to a wider channel bandwidth. Okay, now let's talk about our cables and connectors. Here at Peplink, we have three types of connectors, and in this slide, we show two of them. The most common type is SMA connector. We use different configuration for Wi-Fi and cellular GPS connection, as shown on the slide. If you choose our antennas, we already took care of it to make sure antenna and the router connectors will match. Another type is QMA. This is a very reliable premium class connector. It's very handy connector if you want to connect many antennas in a compact area. You can connect and disconnect QMA just in seconds. Also, and I would say very important, once QMA is connected, you can forget it. It will not disconnect itself. The last type of connectors is N-type. These are a bit bulky in size. However, N-type is outdoor rated and it is recommended to use IP rating higher than IP66 if needed to achieve. Here at Peplink, we use female on the equipment side and the male on the antenna side as shown on the slide. Next, let's talk about the most common cable types. Each of these cables have its own cons and pros. The RG174 is the thinnest one in diameter. The cable is very flexible. Its main disadvantage is attenuation and maximum frequency. Here at Peplink, this cable is typically used for GPS antennas only. The another one type is CFD200, or this alternative LMR200. This cable is thicker and is about 5 millimeters in diameter, but still very flexible. It can be used for signals up to 6 gigahertz, So it covers all LTE and 5G bands. Also, it has relatively low attenuation. So for instance, a 6 feet cable length attenuation for a mid-bands is about only 1 dB. The other two types, LMR 400 and LMR 600, have ultra-low attenuation and are suitable for longer cable runs. These are premium class cables. The main disadvantage is cable flexibility. They are quite rugged. Also, they come at a price. Typically, these cables are terminated using N-type connectors. At this slide, we also added a recommended cable length, which we recommend not to exceed. The main reason is attenuation. Okay, and now let's jump to the second part of applications. Here at Peplink, we have three main antenna product lines. Hummingbird are for fixed installations. Those are directional antennas. Puma are for mobile ones. These are omnidirectional antennas. And Stingray, which were designed at having maritime environment in mind. These are also omnidirectional antennas. Now, fixed installations are most common in low densely populated areas. In these areas, typically indoor antennas are not working or the performance is very low. Therefore, external antenna will help you to increase the signal strength and quality if installed properly. Let's take a look at our directional antenna. We haven't released it yet, but we plan to have them in late summer or early autumn. The antenna will have a high gain of about roughly 10 dBi in certain frequency bands. Also, it will have an active GPS antenna, which is compatible with Peplink routers. The antenna will come in two options, 5-meter cable with SMA connectors and half-a-meter cable with N-type connectors to use with extension cables for longer runs. The enclosure is reliable, UV stable, and designed to withstand high wind loads. And lastly, two mounting options will be supported, pole and wall mounting. Now let's move to marine applications. One of most common question we hear is, what is the maximum distance for the connectivity? There are a couple of factors which need to be considered. However, there is also a physical limitation because of a line of sight requirement for LTE bands. And sadly, but our Earth is round, so we need to know antenna installation height. For instance, if the boat antenna installation is 30 feet above the sea level and base station antennas are 100 feet above the sea level, the maximum line of sight range will be about roughly 22 miles. The actual range may be shorter depending on the antenna efficiency, pattern, gain, output power, and etc. Another thing to mention about maritime applications is the antenna gain. Different vessels have different roll profiles. So for example, a large ferry is not going to roll too much and could safely go for higher gain antennas, where a smaller fishing vessel will probably roll a lot more and require lower gain antennas. You can mix antennas and use lower gain antennas for one modem and higher gain antennas for the another one, but you should always try to use the same type antenna for all connectors on a single modem. Now let's take a look at Peplink Stingray antennas. So as mentioned before, those antennas were designed at having maritime harsh environment in mind. We have two options. Stingray 201 has two LTE antennas and 401 has four LTE antennas inside. Both Stingray models also have integrated active GPS receiver. 201 is perfect for routers such as BR1 or UBR LTE, and 401 is perfect for deployments where more cellular modems are used and reduces the number of physical antennas required when using Cat 18 or 5G models. We have had these antennas tested and they can withstand up to 160 kilometers per hour wind load. And all important to note, metal parts are marine grade stainless steel. Both antennas have the same RF properties. The 401 is pretty much the double of 201. And these antennas will be available this summer. The last type is mobility installations. We have designed a low-profile Puma antenna series, which are perfect for these installations. Let's take a look at the key properties. As mentioned, Puma antenna series were designed having mobile applications in mind. Main things to mention about these antennas are extremely wide bandwidth, starting from 600 MHz up to 6 GHz. This basically covers all the LTE and 5G bands. These antennas have very high gain and efficiency, even when there is no ground plane behind them. The enclosure is IP68 rated, so it's also suitable for marine applications as well. And it was designed to have a very low profile to reduce the wind drag effect if it's installed on a bus or a car or any vehicle. And lastly, the design is robust and made from UV stable plastic. We have many different antenna element configuration to meet all sort of different applications. Okay, now we can see here a summary table of Peplink antenna series. All our antennas are wide bandwidth, covering all LTE and 5G bands. The exception is Stingray, which is actually ultra wide bandwidth, supporting as low as 400 MHz. Hummingbird antennas has the highest gain and will ensure the best possible signal strength, which will lead to the best performance. For mobile applications, we suggest to use Puma series. For maritime, we can offer Puma and Stingray, while for fixed installations, all three types can be used. It depends actually on the distance, requirements like throughput, and etc. All our antennas have integrated active GPS receivers, which are compatible with Peplink routers. And lastly, all antennas were designed to be robust and vandal-proof. By the way, from time to time, we also are asked if antennas can work on Wi-Fi bands. So the answer is yes. These antennas can be also used as Wi-Fi. Now let's have a few words about antenna naming. Antenna naming was designed to make it simple for you guys to remember. At first, we have antenna series name, like in this example, it is Puma, but actually it can be any Stingray or Hummingbird, it doesn't matter. Then we have three numbers, which are the most important. They indicate antenna element configuration. So no matter which series antenna you will take, you can easily know how about our internal antenna element configuration. So in this example, it shows that antenna has 4 LTE antennas inside, 0 Wi-Fi antenna elements, and GPS. The last three symbols are related to the cable length, connector type, and color. Okay, now our antennas come with different types of cables and connectors. The Puma are available in SMA and QMA. Stingray only come with a SMA connector, and Hummingbirds have SMA and N-type options. Also important to note, we have also extension cables which you can connect to our antennas and for longer cable runs. This table is a summary table to show Puma antenna options because there are quite a lot of SKU numbers. And it shows connectors and cable length which are available. I would like to note that each Puma antenna comes in two color options, white and black. So this table will help you to select the correct antenna for your router or application. All of our Cat12 and below routers have two connectors per cellular modem, but starting from category 18, which is on the right of a slide, there are four connectors per modem. The reason for this is additional frequencies are utilized at the same time, and this requires additional antennas. These additional connectors and frequencies allow for higher throughput. We regularly get asked if you need to connect all the connectors to antennas and can I use splitters? The short answer is no. Splitters will not work for sure and will cause issues. And if we talk about connecting half of the antennas, this still might work, but the throughput will be affected for sure. And in this table, we have a recommended or advised combinations of our antennas and routers. For the devices which have Wi-Fi, you can select external antenna or you can use indoor antenna supplied with the router. So this means do you want Wi-Fi LAN and WAN to be broadcast from the external antenna, which is placed, let's say, on the roof, or you can have a Wi-Fi coverage in the same location where your router is located. The slides will be available for download, so I will not focus too much on this slide. Now let's have a look at the typical example of scenario where Cat18 HD4 MPX is going to be installed with 2-meter cables using Puma antennas. So for this configuration, you can use two Puma 401 with QMA connectors and two of 421 with QMA connectors. Our Puma antennas come in 2-meter length or 6 feet length, having a QMA connectors. Now to connect the Wi-Fi, you will also need to convert converters from QMA to SMA. This is just one example, and taking a look at what configurations options we have, you can find a better solution for your application, and you can treat this slide just as a reference. Here is another scenario with the extension cables. So antennas are located, if antennas are located slightly further away from the router, and extension cables are required. Extension cables QMA to SMA are available to purchase from Peplink. Now for this setup, we are using Transit Duo with a free Stingray 201 antennas. Two of the Stingray are used for cellular connectivity and one is used for Wi-Fi. As mentioned before, our antennas support Wi-Fi bands as well. You could also use Stingray 401 and 201 depending on the installation location. The Stingray used for Wi-Fi will need SMA to RP-SMA adapters. On the other hand, for the Wi-Fi part, you could also use Puma 020, which has only two Wi-Fi elements. In that case, you don't need any adapters and you connect directly to Max Transit Duo. Or in certain other applications, you can use just Puma 420, 421, and it will be enough to have only one antenna for this sort of scenario. Let's now have a quick take a look at some advices for the best practice. The first one is no splitters. Splitters literally split the signal which is received. A 1x2 splitter will at least halve the signal, and 1x4 splitter will reduce the signal down below 25%. The best cable is no cable. In other words, try to keep cables always as short as possible. High quality cables will help you to reduce the signal loss. If you are using a cable which we didn't cover, always double check the specs and what is the maximum frequency, what is the loss, and etc. The fewer the connectors, the better. Each connector will increase the loss. Typically, you can count that for every connection, you have a 0.5 dB loss. The actual value, of course, will depend on connector quality. Talking about the antenna placement, place it in the best location possible. Make sure there are no obstacles between the antenna and the cell tower. This is not all, we understand this is maybe not always possible, but it will help you to get a better signal. And the last one, choose always antenna which is best for your application. For more details, we have a white paper, and here is the link which you can download later after the seminar. And I think this is all. We came to a Q&A session. Travis, could you join us?
Yes, absolutely. Thank you, Giedris. That was great. A couple questions came in. I answered those real time over the chat, so I think we'll leave those off. But just two remaining ones that I see here. Feel free to put some more in. There's plenty of time. So if you got other questions pending, type them into the Q&A section here. But first question I see, for live streaming situations, we want a mobile solution. What's the best antenna? Hummingbird antenna? Is the Hummingbird a good option? If so, how to best point to the cell tower?
Well, actually, may I answer this, Travis?
Yeah, go for it, please.
Okay, so it depends where you are. I would recommend using directional antennas only if you are in low densely populated areas. If you are in highly densely populated areas or suburban areas, I would go for Puma, or actually I even would think about the Stingray antennas. The reason why, because you can connect to a couple cell towers, and it happens that sometimes one cell tower is too congested, and then you can connect to another one. So if you want to install antenna on the vehicle, I would go for Puma. If that's a fixed installation, I would think about a Stingray. Travis?
Great. One other one that I think is interesting myself, when using multiple antennas on HD4 MBX, what is the recommended separation distance between them? So I guess I expect that, just using the Puma as an example, there's 4 antennas inside of that one unit. So if you had 4 of those for the HD4, how far should you put each of those 4 apart?
This is a very tricky question. It would be good to have at least 0.5 meter. This would be recommended, but I've seen installations where antennas are put next to each other. And for instance, if we talk about Puma 401 or 421, which have 4 LTE antennas inside, actually those LTE elements are very close next to each other. And when we were designing those antennas, we were also checking the isolation between internal LTE elements. So even if you don't have enough space, you can put them close together. If you have space, 0.5 meter away from each other would be a perfect solution, actually. Travis?
That's great. I think that's kind of my thoughts as well. If you've got the space, use it. If you don't, put them as far apart as you can possibly get them.
Yes, exactly. Sometimes it's just not possible.
Yep, absolutely. I see another question on MSRP. I'm going to punt on that one. You can check with your distributor or Peplink account manager to get the pricing on these models. I think some of them that we've shown are not shipping quite yet, and so again, I would check with your purchasing partner or wherever you're purchasing Peplink devices for pricing information. What I can say is our prices are extremely competitively priced when you look around the market for a like antenna. I think you'll find there's a heck of a lot of value in our antenna products. Another question, marine antennas, are they not recommended for use on land?
Oh, if I can, I will answer this one. So this one is very easy question. The answer is yes, they can be used on land for sure. The thing is that when we were designing those antennas, we focus on the marine environment because it's very harsh. So we needed to make sure that there will be no rust, it can withstand winds and so on and so on. But it will perfectly work on the land. It's actually even, there are less requirements for the antenna when it's operating on land.
I think one of the other considerations there too is just clearance. If you compare like a Puma Omni antenna to the Stingray Omni antennas, the Stingrays are very tall, which, for a land vehicle would generally not be a good idea just because it could run into obstacles. But on the boat, there's not much above you usually, so we can get higher gain omnis and create those formats there. But if it's a stationary application where clearance isn't an issue, I think it's perfectly valid. I think Giedris, like you showed the
Yes, you are completely right. I have nothing to add actually.
great. One question, are there regulations dictating the use of all of these antennas in the UK, and are all of these antennas compliant? I don't know what UK restrictions there are. I don't know, Giedris, do you have any comments on that?
Typically, how it is done, it's specified with the modem what is the high or what the allowed antenna gain is. But when we were designing, it is there should be no issues when using in the UK because those antennas when we design it, we are focused on United States and EU, including the UK, so it should be fine.
Great.
I would like also just one thing to know that antenna is not an active component, so there are less in general regulation for the antennas. So there's no actually such thing as certification or anything.
That's a good point. It's much different than like a power amplifier where there's
Yes,
plenty
correct.
of regulations.
Exactly.
Okay, another question. What type of pole, metal versus fiberglass, is recommended for a remote trailer installation, and what is the maximum height? I think that's a little bit out of scope. I think one thing I can point to there, Giedris, is just the wind loading. I think we specify a wind load value on our antennas, if I'm not mistaken.
Yes, correct. Yes, absolutely.
So I think that's a factor in that, but I don't know the material properties well enough to comment on what the maximum height would be.
If we are talking about the antenna installation height, then the answer is very simple. Always try to keep it installed as high as possible, and because it will help you to avoid a lot of obstacles and get the best possible signal.
Yeah, I think that's a good point. What I know just in practice for myself, you run against the balance of, how much cable loss do you have, right? So if you're going to put it up
Yes,
very
correct.
high, you've got cable loss to compensate for, but sometimes getting above a lot of attenuation can make up for a lot of that cable loss that you might experience. So there's no right answer there, but a few factors to consider. Okay, another question. How stiff are the Puma antenna cables? What's the diameter of each? Bends and pipe size being the consideration?
All our antennas for LTE are using CFD 200, which is 5 millimeters in diameter. And for GPS, we use RG174 cable, which is 2.5 millimeter, if I'm not mistaken. These cables are quite flexible, and should be no issues bending them actually. Um, I guess that's it.
Yeah, I've found them to be quite flexible. It's, you know, like you mentioned earlier, the cable size, the larger the cable, the less flexible it is, but that included cable on there is pretty easy to work with from my perspective. Okay, another one. What is the antenna gain for the Stingray at various frequencies? Is there a data sheet published yet? There is a data sheet, definitely. I'm not sure if that's published. Gidris, do you know if that's if the string?
I think it's not officially published. We published to our partners, some of them. If we're talking about the gain, it goes as high as 6 dBi on certain bands, but I don't have a data sheet now on hand. Cannot answer how about what's the gain in certain bands. What is the important thing to note? When we were designing Stingray antennas, we also checked the performance on the lower bands, as that's quite important for maritime applications. As if you want to have a long range, you're operating in low bands like 700 or 800 megahertz. So this is only one thing I can add.
Those are those generally the frequencies that can reach kind of furthest from shore?
Yes, exactly. I mean, if you want to have 20, 30 miles from the coast, so these are the bands you will be operating.
Okay, great. I see one question. I don't quite. Let me read here. There's another follow-up. Okay, one question. Do you recommend a more lightweight, less intrusive antenna for use in cars for just kind of general business use? I would say our Puma series is really an ideal you know, road vehicle antenna in my opinion. It's very low profile, but still a good balance of gain and performance.
From my personal experience, we, in such small factor, we have the best antenna currently in the market, at least based on our benchmark testing in third-party labs against other competitors. So far, we
Yeah,
have the best performance. And this was, please correct me if I'm wrong, also confirmed in the field testing. Is it right, Travis?
yeah, I think you bring up a great point that, you know, you went through a lot of different elements of the antenna's performance metrics, and all of those are very important to consider. And I think one thing that I've noticed a lot is other vendors don't, number one, don't always list all of those values. Number two, they don't always do that great on some of those less intuitive values. You know, that they'll state a very high gain, but the efficiency is very
Yes.
low, or there's other parameters that kind of subtract from their performance, but it would appear as though they're doing better. So details matter a lot on those data sheets. And I think there's a good story from a partner of ours in the autonomous driving field. They took several competitive antennas out there on the market, similar to that Puma 401 that we have, and they just drove their vehicles all over with a Puma antenna and a couple other competing antennas, you know, of that similar 4-in-1, 5-in-1 type of format, and they just data logged everything. So they had 4 modems, 4 antennas, and the Puma hands down won on, you know, just over lots of road miles, lots of drive time. You know, it's results like that that really matter the most in the end, is what you get out in the field. And so I would agree, Gidris, we've really created a superior antenna here. And again, the price point is just really hard to beat. Another question. Was there any design challenges for band 71 or sub 700 megahertz? What considerations are there for improving lower frequency signals?
Um, I'm not sure what changes we done from the starting. We were thinking about band 71. So when we were designing antennas, we were testing also 600 megahertz as well. And for those who want the best performance in band 71, we can offer our new Puma antenna 41. This is for mobility applications. And we just did benchmarking with also one of our famous vendors, antenna vendors, and we got same performance for MSRP price twice lower. So in general, to answer, all our antennas can work in band 71. And then depending on your application, you can choose which fit best your application.
Yeah, I think the other comment I'll put out there, on the lower the frequency, the larger the antenna element required to get more gain. So
Oh, that's a very good point. Yes. Thank you, Travis.
it's just a physically challenging frequency to achieve high gain in. And so, the numbers may appear less impressive when you compare it to like the really high frequencies on the gain. So, but again, the balance there is that those low frequencies travel farther. So even though the gain might appear relatively lower, you'll still get much better performance and better range when used on those frequencies.
Yes, and this is what actually happened when we were designing Puma 41. It's a larger size, but we improved almost, I would say, double performance in band 71. Compared, if we compare Puma 401 and Puma 41, so performance in low bands is double times better.
Awesome. Yeah, I'm anxious to go try out that new antenna. I haven't had a chance to yet, but looking forward to that low band gain. Okay, I think, oh, there's a couple more. Oh, how tall are the Stingray 201 and 401?
Roughly, it's about 40 centimeters and about 80 centimeters, including the marine mounting.
Okay. One other question, what's the size dimension of the Puma? Is it relatively large or small? I think you mentioned the first several Pumas were, I would say, relatively smaller, and the newer 421 is a little bit larger, but similar in size, I guess.
I think the smallest ones are 13 centimeters in diameter and about 3.6 centimeters in height, while 41, don't remember exactly. I think it's about 15 or 16 centimeters in diameter, and height is about 6 centimeters, I guess.
Okay.
So it's quite a low profile, actually.
Yeah. Yep. Okay, I think that's everything. If anybody else has a follow-up that we didn't get to, give us a shout on the Q&A here. We'll give you just one more minute. Otherwise, I think we've covered all the questions in here. Again, Gidris, thanks. I love the material in here. There's so many elements that I've learned over the years that are all in this one presentation. So to me, it's really a great collection of a lot of different knowledge that, again, really does matter when you're out in the field and trying to get the best performance out of your antennas. So thank you, Gidris, and thank you everyone for joining.
Yeah, thank you, everyone.